Yeah, thanks. You should see my screen, including my video. Thanks for the introduction. Yeah, so could you show up the first poll, please? For those on YouTube, the first poll is about, have you used some AI, ML-based technologies over the last 24 hours in the last day? Yeah, so the goal of my talk is a little bit to, maybe put AI, ML down from that high stand that it might have at the moment. In particular, as I have the feeling that a large fraction of the cybersecurity vendors, and we heard that already in the last talk, are a little bit bipolar. On the one hand, they're a little bit depressive, telling people how insecure everything is. And on the other hand, they're a little bit overactive and have very high feelings about what technology can do. And I'm trying to balance that out a little bit. So let's see how things look like. So if you might have heard, and if you are thinking about ML and AI, maybe one of the first big success stories of AI that went out to the general public a couple of years ago was AlphaGo from Google, an AI system that was the first computer program that has beaten a human in the Asian game Go. And while we have for quite a while computer programs that play chess very well, Go has much more possibilities to place pieces on the board, and therefore is much more complicated for a computer. And actually, it was estimated that it takes much longer to have a Go program that is able to compete in a professional league. Also, we have new artificial intelligence techniques that animate pictures. So you have a picture or the image of Mona Lisa and they turn it into a video, let Mona Lisa smile. So that's really astounding what is actually possible. And also completely different fields like biology and medicine benefit from AI. For example, improving gene sequencing or classifying protein structures. So it has a wide application area. And we see from the poll, it's already going away, but it was roughly 50-50, I think 49 to 51%. So half of us kind of had contact with an AI system. Maybe the other half didn't know that they at least were using a system that was, at least from the manufacturer's perspective, claiming to use AI. So let's have a look. What does AI actually mean? What is kind of the core idea? The core idea is you take a data set, data information that you have available, you do some initial analysis, and then start using that data to train something that we later call the intelligent system. And I'm using here artificial intelligence and machine learning synonymously, so I'm not distinguishing in detail about those two, and please forgive me if you're an expert in that area, but I think it's not necessary for most of our audience. And then if you have a trained network, a trained system, you deploy that system and use it. You feed in new data, and the trained model should then give us predictions or analyze that data, give us more information about that data, maybe classify if something is an attack or a benign usage of a network or a PC. That's the core idea. And the nice thing, and why many people are so excited about AI, is there is no programming involved. There is no complex technical, mathematical, algorithmic step there. It looks like, we train a system like we would train a small child, and then it's suddenly able to fulfill its task. That really looks great. So the first observation that we make is, if we want to train systems for security, we need high quality data to actually start that learning process. It's sadly not the case that you just take your Cyber Essential Guide, put that to a computer, let the computer read that guide, and suddenly you have a trained security expert. You need to have good data about previous incidents, about human assessments of those incidents, for example, that the machine actually can learn from. So for the rest of the talk, I will go over those four topics quickly. Couple of examples in using machine learning and AI for defending systems, so for improving the security of systems. I will talk a little bit about areas where machine learning and AI could be used for attacking systems, so more kind of where the threat actors might use it. And then I will talk about the security and safety of systems that use machine learning and AI. So how trustworthy in a certain way are those systems, and touch at the end briefly a couple of challenges. And one challenge we have already seen, we need data, and we heard that already in the previous talk. There is a certain problem in getting reliable data, even to do simple statistics about how many attacks do we actually have and how many of those are successful. So one area where machine learning and AI is actually widely used and heavily advertised at the moment are intrusion detection systems. So systems that you install in your network that analyze your network traffic and send you an alert if the system believes there is an intruder in your network, so that you can act timely and improve the protection of your system. Traditionally, those systems have been implemented by human experts that defined weird-looking network patterns. For example, let's say some internal servers trying to do connections to the outside internet, which might be indicating that there is some ransomware or some malware running on that server and trying to connect to something called a command and control server, so a server that is under control of your threat actor and that is trying to hijack your server. And nowadays we have a lot of systems that actually are trained on real attack data and generate, so to speak, those patterns automatically. And the big hope is that by using much more data than a human could analyze, that those patterns, that trained model that we get after the training phase, covers much more attacks and covers attacks more precisely, so also has less false alarms than when a human would define them. So that's a great area where we see already a lot of products also on the market that have a big sticker on the box. If you still would have box software being sold in boxes, this product includes a lot of AI and machine learning. In a similar space, your virus scanner or more broader malware detection system works on the same principle. Also here, traditionally, those systems have been using manually defined signatures, which means some expert were looking at the malware, were trying to identify some patterns in that malware, some characteristic code pieces, text fragments that might be stored in that malware that could then be used by an analysis engine that a human implemented to detect those malware. And that is, again, a timely process, a time-consuming process. It requires a lot of expertise, and the systems that have been previously developed are mostly static. They mostly look at the software that you download from the internet, try to analyze it, and if they say, yep, it's fine, then they allow you to execute that software. The more modern machine learning and AI-based systems, they are again trained on real malware, again trying to learn or generate those signatures and patterns themselves. And given that the training phase is, at least from a human perspective, cheap, it's computational, very expensive, but it doesn't cost expensive human labor, we can now also much more efficiently and broader start trying to train those systems not only statically on downloaded software, but also observe the behavior of software while you're executing it on your machine, and turn a malware detection system from a rather static system into a dynamic system that then later on can also react on, again, suspicious behavior of your software, of your applications that you are using. Let's say a text processor suddenly trying to open up network connections. Then you might get those alert boxes that you have on modern systems like your word processor is trying to connect to, I don't know, template.office.com, and you say, yeah, that sounds legitimate. I would like to download some templates. I'm just creating a new letter or a new presentation. But if it suddenly tries to connect to some banking server or some strange server with domains that you don't know of, you will tell the system, no, that's not good. And the system will try to adapt and learn from that. Great. These are two areas where machine learning works to a certain extent, or works pretty well already. And those two areas have two things in common. We have something like over 40 years of experience in malware detecting and network analysis. I had already virus scanners running on my computers in the 1980s. And similarly, people did already do network analysis. So we have a lot of human experts with years of experience, and we have huge data sets that already have been analyzed by humans for those traditional systems being implemented. And in those two areas, industry is actually willing to share data. There is, for example, a service where you can upload malware and it's analyzed by 20 or 30 different virus scanners, and you can get the results back. And that service is also sharing the data among the different vendors of the malware detection systems. So even so those companies compete in the same market space, they're willing to share patterns and data, how attacks look like. And that's something which makes AI and ML systems in that area very successful. Still, if you look at the evaluation, how well do those systems work? AI and ML systems outperform traditional systems and human experts in specific areas, but there is not one system that outperforms them in all. And there are different techniques in machine learning and AI that work differently well on the different attack types. So there's not one silver bullet, even in that area, which is kind of a sweet spot for those techniques. Let's move to the offensive side. If I would be on the offensive side of security and would think about where actually is a sweet spot for me for using machine learning in AI, I would come up with doing some open source intelligence. So learning about people, what employees of a company, for example, posted in social networks, what I can grab from visiting company websites or university websites, to then use that information to, for example, mount a very specific spear phishing attack. So a phishing attack where I'm addressing a very small number of people and have very specialized emails, for example, sent to them that refer to a very concrete work context or personal context of them that I obtained by analyzing all their social network posts, for example. Again, here I'm in a sweet spot area because there's a lot of data available. The social networks themselves use machine learning internally, for example, to suggest new connections to you or content that interests you, so that data is already in a format that makes it easy to analyze. And a lot of those social networks are actually willing to share their data to a certain extent. So that would be kind of the sweet spot area where I would be starting my work on machine learning and AI for attacking other people's businesses. An area where people actively doing research in improving existing security techniques, and that is something which, as many tools and techniques in security can be used both for the defensive as well as the offensive side, is vulnerability scanners and security testing solutions, and trying to reduce wrong alerts by those systems, the number of wrong alerts, by applying machine learning. And that is something which I also did in industry. And as Rob already mentioned, I was working for a company with something like 25,000 software developers in-house, where we had the full data available about the software they were writing, the security problems that happened in those pieces, plus we had all the publicly available information about software vulnerabilities. And if you browse your news websites or so on, you will get the feeling that there are so many software vulnerabilities that you should be overwhelmed with data. But actually the experience is, if you then want to develop a machine learning AI system that improves very specific security testing techniques, you certainly need to drill down that data into, I need that for certain software written in certain programming languages. I can only work, or I'm focusing on certain vulnerability types that actually can be detected by those techniques, and for example, that do not involve human interaction or phishing attacks. And then suddenly you end up with a data set that contains 20 vulnerabilities. And that's not really a large data set to do machine learning on. So that was actually also a surprise to us, that even so it looks like there is terabytes of data available, you end up with 2 handful of really interesting data sets that you can work with, and the rest of the data is either not usable because it's out of scope of your current target, or the data is of so low quality that it's not useful. So even so, sometimes it looks like there's data available in large quantities. That's not the case. So that is an area where it is interesting to look at, but my personal opinion is it will take another couple of years before we really see a successful application of machine learning in that space. So let's have a look at the security and safety. So here we are looking at systems that use machine learning or AI. So let's go back to what machine learning and AI actually is. So we said we use data, we use the data to train our system, to teach our system. Then we have that learned model, and we use that learned model for making decisions for new data sets, for new information that we get. Okay, what does training actually mean? Again, it's not like here's a book, read it. It's more like here is some data, and overly simplified, real data sets have many, many dimensions. I used here only a 2-dimensional vector space or space. It's kind of draw a function, draw a graph through those data points. And as a human, yep, we can easily do that. That roughly gives an approximation, and now we could develop a system that decides if a new data point is below or above that graph. Fair enough. If we let a machine train on that data set, the result might look like this. It's a little bit off, but still looks fine. Not too much of the actual data points. But given that the real data is very complex and has many dimensions, much more compromises need to be done. So your trained model might actually more look like this. While you would have expected something like that yellow line, and all those orange amber highlighted areas are now kind of areas where your machine learning AI system for new data behaves slightly differently than what you would expect. The problem with those AI systems is that we only have that trained model for that approximated function, but not a concrete instruction how the system behaves that we can look at. So we need to analyze the system. And that can result in funny behavior on the one hand. So image recognition is one of the prime areas for machine learning. It's actually an area where machine learning-based systems outperform humans in many areas. So if I have a photograph of a panda, an AI system will easily classify that as a panda. I can send garbage to that same trained system. And here in that example, and that's a real-world example of an ML AI system, it comes up with, this is a nematode. That looks weird. I can then combine both pictures to a human that still looks like a panda, but that machine learning system comes up with, oh, that's now a gibbon. That's funny in a certain way and doesn't look too problematic. But let's assume that it's a system that runs in your autonomous car. Then suddenly that becomes a safety issue. I modify that stop sign a little bit, and the system might classify it as a speed limit, and your car is no longer stopping at the traffic sign. And of course, if then an attacker, a threat actor, is actually changing that sign a little bit, and we know of examples where people put some duct tape on street signs to bring the MI system into misclassifying street signs, then suddenly that also becomes a security issue, and we have a real-world attack. And there are plenty of those examples. Something that was being published in the last couple of days and surprised people is that, yeah, actually we train machine learning systems in text recognition. We also train them in image recognition. And yes, if you combine them, then suddenly you get a system that can do both and might result in a surprising classification. So if you have a poodle and you put some dollar signs on top of it, then suddenly the system classifies it as a piggy bank. And if you have an apple, it properly classifies it as a Granny Smith, a green apple, looks fine. If you put a sticker on it and claim it's an iPod, then the system believes you. So somehow that system seems to trust written language more than what it actually sees in the picture. Fair enough. And again, that's kind of a funny example, but you might have also heard about systems that do face recognition. And at least at the beginning, and given recent news, it still seems to be the case that all the image recognition systems have significant problems with recognizing faces of people of color. So if you have a darker skin, then suddenly the system doesn't work that well. And of course, we use face recognition also in a security context. And we need to ensure that the systems are not biased, because otherwise we end up with artificial bias instead of artificial intelligence. And that's definitely not something that we want to have. And also, it reduces our trust into the system, and it's questionable if you want to use those systems for security critical applications. So misclassification can have severe impacts. And the worst part is, we have no idea what went wrong. We are missing that kind of algorithm, source code, that whole human written part that we otherwise would analyze and look for a bug. Somewhere the data set was not right that we put into the system. So in those face recognition examples, the data sets that were used for training only contained faces of people with a rather light skin. And therefore the system never learned about that people also can have darker skin or different skin colors. So the mistake already started with the training of the system. And there is that funny quote, changing random stuff until your program works is bad programming. But if you do it fast enough, then it's machine learning and pays 4 times your current salary. Sadly, in some areas that seems to be true at the moment. And that's something where we research-wise are interested in at the university, developing techniques that help us to train systems in such a way or ensure that trained systems are behaving well, whatever well-behaving means in that context, but that we don't have that kind of hackish feeling when doing machine learning and AI. Quickly coming to the challenges. One challenge we already had, we have a lack of data. Available data sets, in particular for security, are often small, outdated, biased. People publish data sets with attacks, but not about regular network behavior, for example. And then you have in your training set an attack every second, where in the real world you only would have a severe attack every couple of weeks. And that can lead to misbehavior of ML and AI systems. So if you have data, consider sharing it. Of course, we need to discuss in what form it can be shared, but to make society secure, more secure, to allow companies to develop systems that help you to secure your business, actually those companies need data that they can work with to actually recognize attacks. And that's one of the problems that we have, because security issues are immediately considered to be confidential and companies don't want to share them. The other part is not everything what is currently being called machine learning or AI by vendors is actually AI and machine learning. And if we go back to that very first explanation, what I did there actually is more like statistics or approximation of functions, because the important part that AI systems are expected to do, react on new behavior, is missing. What we also need to do is, from the new data, feed that into our training loop to actually adapt the system and retrain the system so that it really also can react on behavior that wasn't in the initial training set. Otherwise, we only get a system that can do classifications based on whatever it initially learned. And if then important events are not in that initial data set, our ML or AI trained system will fail in those areas. Okay, with that, thank you very much. Personally, I think we are currently at an AI ML peak of inflated expectations, so at the top of that Gartner hype curve. It is not the silver bullet, but it is an important and valuable tool in our security toolbox. From an employment perspective, I don't think that a lot of security experts will be replaced by machine learning or AI-based systems. They will use them and complement them. And I think the really valuable use of those tools is still lying ahead of us. Thank you very much. And with that, I hand back to Rob.